Okay, so for my final question, I have the integral of x squared over x to the 4 plus 4 dx, which when I looked at it didn't look bad at all, but it's probably the worst question I've done all my life. I never wanted to do this ever again. It was horrible. Okay, so after just staring at it for a while, I just decided, like, why not? Let's just figure out a way to factor out the bottom. So I did, and if you actually expand this, you get x to the 4 plus 4 because these terms here all cancel out. So after that, I was like, okay, where do I go from here? And the only thing I can think of is just by doing partial fractions, which everyone obviously loves. So I set up the equation like this. So I have x squared over that entire x squared minus 2x plus 2 times x squared plus 2x plus 2 is equal to ax plus b over x squared minus 2x plus 2 plus cx over plus d over x squared plus 2x plus 2. Okay. Now, after just cross multiplying, you get x squared is equal to ax plus b, x squared minus 2x plus 2, and then cx plus d times x squared plus 2x plus 2. And after careful expansion, it took 2 lines, but this is the final thing that I got. And just keep in mind that's a minus and not a plus. So I got x squared is equal to ax cubed plus 2ax squared plus 2ax plus bx squared plus 2bx plus 2b plus cx cubed minus 2cx squared plus 2cx plus 2dx squared minus 2dx plus 2d. Okay, now this part actually isn't as bad as you might think, because what I'm going to do, I like to have little subsections. So I have my little x cubed here. So the only coefficient here for an x cubed is 0. And there are 2 coefficients here, so a and c. So 0 is equal to a plus c. So now we know whatever value we get for a is actually equal to negative c. Okay? Then what I did was I said x to the power 0, which is just any like constant or number that we see on the side, which is we don't have any, so it's 0. So we get 0 is equal to 2b plus 2d because those are the only ones with x to the 0. And with that, we get b is equal to negative d. So I also did x squared, which as you can see here, we have 1. So the coefficient is 1. So we get 1 is equal to 2a, right? And then just 1b minus 2c and plus a d. So by subbing in this, no, actually I subbed in this one first. By subbing in a is equal to negative c, you get 2a plus b plus 2a plus d. And then we sub in b is equal to negative d. So you get 4a plus b minus b, which cancels out. So you get 1 over 4 is equal to a. And now because we know that a is actually equal to 1 over 4, and a is equal to negative c, therefore c must be negative 1 over 4. We also had another one that was x to the power of 1, and the coefficients are 0 is equal to 2a plus 2b plus 2c minus 2d. And so now we know what a and c are, and in fact they actually cancel out. Then we have 0 is equal to 2b minus 2d, and then by using this, b is equal to negative d, we get 0 is equal to 2b plus 2b, which doesn't really matter because anything divided by 0 is 0, so therefore b is equal to 0, which is equal to d. Okay? So now we know a is 1 over 4, b and d are 0, and c is negative 1 over 4. So we are going to plug that in here. And we're going to get 1 over 4x over x squared minus 2x plus 2 minus 1 over 4x x squared over x squared plus 2x plus 2, because this minus corresponds with the negative of the c. Okay? This you might think we're almost close to being done, but we are not even nowhere near it. Okay, so I am just going to show that I plugged it in here. I just basically moved what I had here into the original sheet, and I just factor out the 1 over 4 because it was common between both. It just makes it a little less clustered. And then I didn't know what else to do, so I just split these two, the two separate integrals. So I had 1 over 4 times the integral of x over x squared minus 2x plus 2 minus the integral of x squared plus 2x plus 2. Now, what I did here is just sit for a while and just look at the question and hope something comes to me. And what I did was basically a little bit of magic. I mean, it's not magic, but like just thinking of it, coming up with it was magic, but the way it works nicely. All right. So what I said was, okay, I can try to change this into a ln. I would have to do that by doing a substitution. So if I were to substitute something, I would say u is equal to x squared minus 2x plus 2. Okay? So when you derive that, you get du is equal to 2x minus 2. But what happens here is if I want to, if I actually want to have a nice, like, integral, my integral would have to be 2x minus 2 over x squared minus 2x plus 1, right? Because when you sub all of that in, when you sub in u, you actually get 1 over u du, based on the information that we have here. And this would easily become ln absolute value of u plus c, right? But that's not what we have here, because here we have this x, which is the bane of my existence. So what I have to do here is, I was like, I gave up. But after a while, I've discovered, what if I can change this x into a 2x minus 2? So after some like basic algebra, you can figure out that 2x minus 2 divided by 2 plus 1 is actually equal to 2, right? So I started off with a 2x minus 2, and I said, okay, if I divide this by 2 and then add a 1, I would get what I have at the top. So that's what I did. I subbed in this here into my integral. And let me just zoom in so you can see better. So now we have half of 2x minus 2 plus 1 all over x squared minus 2x plus 2. So we're trying to integrate that. Now because we have this whole thing here, and then we have a plus 1, right? What we can do is just split the integral up. And by doing that, look, we created the exact same thing that we had here, right? Except there's just an extra 2 here, which doesn't even matter. Doesn't affect our integral at all. Just the basic integration of it, right? So, based on these substitutions, what we're going to get is we're going to get the integral of 1 over 2u du, which is very basic, easy to do. The second part, I didn't know what to do, so I just completed the square. So I got x minus 1 squared plus 1. And then 1 all over that. And if you look at this long enough, you can tell that it's actually, it is actually the arctan of x minus 1. And if you're not convinced by that, I can just do a substitution to prove that. So you get x minus 1 squared plus 1 dx. So we can say let u is equal to x minus 1. We get du is equal to dx. Am I even in here? No. Alright, okay. So again, sorry about that. I did the integral of 1 over x minus 1 squared plus 1. And I'm doing substitution of u is equal to x minus 1. Therefore, du is equal to dx. And so now, what we actually get is 1 over u squared plus 1 du. And that is easy to identify as being arctan u plus c. Then you sub in u, and it actually becomes arctan of x minus 1 plus c. So all I did here was prove how I got to this step, okay? On an exam, you can just, if you see it like I did, you can just plug it in, because this is one of the equations that we are actually allowed to memorize. Pretty sure. Alright, so now we are left with half ln of absolute value of u plus arctan of x minus 1. And all we have to do now is plug in the u value, right? So that's x squared minus 2x plus 2. And we have, actually, let me zoom out. I added a plus c here. It's not necessary because we've only done half the question, but I mean, to keep proper format, I just like to have it there. This is what we have for the for this part, where is it? Here. For this part of our question. We still have half of our question left. So next, but this part becomes easier because now we know how to use the magic trick. So we're going to do the exact same thing here. 2x plus 2, right? So the only difference is last time it was 2x minus 2, and now it's 2x plus 2 because of the positive here before we had the negative, right? So, u is equal to x squared plus 2x plus 2. du is 2x plus 2 dx. And we get the same, almost identical to the one at the top. Just the only difference is here we had a plus 1, negative 2, again, plus 2, negative 1. So I'm going to split it up again. Using this substitution, I am going to get the integral of 1 over 2u du, which is the exact same thing as before, except the u value is just different, minus the arctan of x plus 1. Because when you complete the square for the bottom part here, you get x plus 1 squared plus 1. Okay, and now we just integrate this part here. You get half of ln x squared plus 2x plus 2 minus arctan of x plus 1, again, plus a c. So, that, when you put it all together, let me actually bring it back. So from the top we had half of ln x squared minus 2x plus 2, and we were just subtracting that because of subtraction here from half of ln x squared plus 2x plus 2. So with the, you can see both of them here. So what we're going to do is, because it's a subtraction between the two integrals, what we can do is use the basic ln formulas and say that ln of x squared minus 2x plus 2 over x squared plus 2x plus 2 is actually equal to this guy being subtracted from this guy. And I did factor out the half, and again, based on ln properties, we can say that this half is actually just the square root of this whole thing, right? Which would actually get rid of our absolute value, because for it to be a square root, it can actually be a negative value, right? So that's what happened there. And then we have, here we have arctan x minus 1, and then we're subtracting it from the second one, which is minus arctan x plus 1, so it actually comes out to arctan of x plus 1 plus, because of subtraction here and the subtraction here. So we get arctan x plus 1 plus the arctan of x minus 1, and they're all multiplied by 1 over 4 because that's what we had way in the beginning here. And of course, let's not forget our friend, plus c. And that is basically, so we go from this nice integral here, I mean, it looks pretty nice, to 3 sheets and this ginormous equation here. Thank you.